gentlemen, and welcome to our presentation with the title Challenges of Using Digital Fabrication Techniques for Design Education in Countries with Developing Educational Level. The paper is written by Dr. Katharina Richter and myself, Dr. Thorsten Lunker. We are both professors at the College of Arts and Creative Enterprises at Zayed University in the UAE. Arts and design education in countries with developing preliminary educational level often follows traditional methods of teaching, similar to and partially adopted from programs in the United States and Europe. Unfortunately, these teaching paths often pay no great attention to the specific preconditions that preliminary education in these parts of the world entails, but that constrain the intellectual capabilities and mechanical skills of the local student body. So while students in the Western world are usually equipped with a good level of craftsmanship, students in these countries often fundamentally lack these skills. Using the example of the UAE, we discuss these missing life experiences through which others gained the mechanical skills necessary to design or craft models, prototypes, or products of their respective arts or design discipline. Many of the students have never renovated an apartment, repaired a bicycle, fixed a broken toy, or even felt an absolute necessity to develop these skills. Our research addresses the educational challenges and opportunities that arise from the use of innovative fabrication technologies, and especially robotics in an environment with such limitations. So we research the impact of these technologies onto the quality of the students' work, and we derive answers from these works to adjust or maintain the direction of current and future curricula. Even though the target group that we address consists of local students only, we expect the results to be transferable to other homogeneous groups with similar deficits. The context of our research is built upon observations that we have made with a cohort of 19 students from a furniture design class in the spring 2018. And furthermore, some of the observations are also manifested through experience with individual students over a period of 2 years in the past. The demographic of this cohort was a homogeneous group regarding gender, female or female students, age group 20 to 23, discipline 95% from the design disciplines and 5% from the arts, all in semester 7 to 9 in the year of study, and all studying for a BFA. And none of the students has actually ever operated a robotic machining center. Less than 5% used 3D printing, but 100% had experience with laser cutting, and the software packages that they were introduced to beforehand were Illustrator, Photoshop, InDesign, and Revit and similar programs. The rationale behind our research is based on 11 theses that address the demographic background of our students, as well as their preliminary education, social trends, and also traditional and modern pedagogical approaches. But none of the below aspects that led to the formulation of these theses is by default good or bad, right or wrong. And aspects that were lacking in a student's education and that one might see as a deficiency to reach a certain educational goal might have never actually been an important element of family or school education for maybe very good reasons. So by way of example, in an environment like the UAE, with its harsh climate, the opportunity to ride a bike is minimal, and so is the necessity to repair a bike. It's almost never given. So the skills to fix a damaged bike, to develop alternative in case spare parts are not available, to rethink a bike's method of operation, and the bike here is just a placeholder for any other technical object, is simply not practiced. So activities that are culturally not endorsed might also be cogent reasons for not gaining a certain skill, and therefore the thesis help to identify causes for some of the issues that our education system faces when traditional practices that worked for decades in the Western world fail in the local environment. They are only intended to identify alternative methods of instruction and should challenge those that teach in similar environments and reflect on their own practices. The first thesis says that preliminary education in the UAE through schools and family pays just a minor respect to the development of manual crafting techniques. That might actually be true for many other countries and regions as well. And respectively, the level of craftsmanship amongst the students is considerably low. And this lack of manual crafting experience then indeed leads to the fact that it is very difficult for students to understand how objects are principally designed or how they are constructed. It is also very difficult for our students to make up for skills that students in the Western world have gained through maybe 20 years of life experience, simply because there has been a different environment where they grew up. And we believe that it is necessary to then develop alternative methods of instruction that actually refer to the current situation, to the local situation. Digital fabrication techniques, on the other hand, as well as robotics, have proven through industry applications that they are very well suited for the creation and assembly of products in a very short time frame and with very high precision. That is pretty similar to how the art and design disciplines work, because they use similar processes, and this is why we think that these techniques can be successfully also applied in our disciplines. And the good thing is that local students have a vast experience in the usage of digital devices. They're really good in operating mobile phones or gaming consoles. And digital fabrication and robotics are operated in a very, very similar manner. So we expect that students do not really have an awful lot of problem, or that we do not need an awful lot of time to teach them these kind of innovative technologies. Students can also operate devices without having an inherent understanding or an understanding of the inherent principles of how they operate. So traditional approaches where students must read a manual, get formal training, might actually render obsolete. And I think we've all seen that before, that students can operate their phones without really understanding in detail how these phones work. And that is something that is maybe possible to transfer to other devices as well, but maybe not necessarily to devices that are a potential safety hazard. The capability to operate such like fabrication technology, then we assume, enables our students to create a much larger amount of products or prototypes just simply through experimentation. And we believe that these will certainly increase the quality of the products. That increase in product quality through the implementation of digital fabrication techniques might then also render parts of the actual curriculum obsolete, because you simply might not need to teach traditional techniques anymore. And we've particularly made this experience with regard to drawing, where we saw that drawings were very often erroneous, but nonetheless, when they were applied into a practical approach to manufacture objects, they kind of were not given the importance as we've done in the past, because students were able to figure out how to manufacture objects without the need of referring to a specific drawing. We also think that many disciplines in art and design share the same principles, and this is why we believe that our education should be less oriented towards individual programs, but much more toward the development of competency in shared disciplines. And certainly knowledge in the area of digital fabrication and robotics is a core competency of the information age, and thus students that acquire these skills makes them an extremely competitive factor of the international arts and design market. These techniques have already just begun to impact art and design disciplines in a very, very positive manner, and the future extension of these techniques will certainly improve the quality of the student work. The technology that we have used in the course could be divided into low-tech as well as high-tech machinery and tools. And to be honest, it wasn't unexpected that students were not averse in using high-tech machinery, such as the Robotic Machining Center. And they actually were engaged in all aspects of setting up the robot base, positioning the part to be machined, as well as operating the robotic device. And it is assumed that this is since failure in the robotic operations are often not immediately observed as someone's personal failure. This is entirely different with low-tech devices, where we felt that the source of the problem is usually evident. It is very often one single person that is not able to hold a hammer, who's not strong enough to use a saw, or who doesn't know the direction of how to tighten a screw. In very rare cases, it could indeed also be a malfunctioning tool. Observations in regard to interaction with technology were that students were actually very confident in using any kind of digital technology, even if they have never operated this type of technology beforehand. They were a lot less confident in using traditional electrical tools, and they were completely unconfident in using manual tools like saws and hammers and the like. However, it doesn't really mean that this confidence automatically leads to a better product. So simply just because they do not fear, do not have any anxiety to use a robotic device, it does not mean that they can actually master it. And on the other hand, unconfidence does not necessarily lead to a product that is worse. In regards to our observations, that what we call misinterpretation of facts, we figured out that students very often chose the wrong tools for the given tasks, and that they produced, for example, unfeasible drawings, no matter if they were digital or analog, that they didn't properly plan specific tasks ahead of time. But astonishingly, neither these inaccurate drawings that were in the wrong scale or that had constructive shortcomings hindered the students to fabricate these objects, because very often they figured out it doesn't work the way that they wanted it to work, and they had to develop alternative solutions on the fly. This is because of they were missing the foresighted planning, and they often succeeded with that. So interestingly enough, they didn't actually need to use the drawings all the time. They could simply refer to the ideas that they had in mind and then just do it. There's indeed an issue that happens in many institutions around the world, and familiarity with digital technology also has a downside in terms of students having access to a plethora of different sources. It is not rare that the borders between reasonable design influence and inspiration on the one side and intolerable plagiarism on the other dilute. It is also beyond question that plagiarism cannot be in accord with the university's code of conduct. But however, having a look at countries such as the UAE reveals that there are a multitude of influences in all aspects of life that do not originate from the region. Architecture, food, transportation, business concepts, people, all of these constitute an environment almost incomparable to any other region in the world. So understanding what a tolerable, desired influence is in contrast to an intolerable replica is sometimes very difficult to grasp for those that grew up in such a rapidly changing society. In this regard, we suggest an approach where influences from other works, if not completely plagiarized, can be accepted as a basis for further development. Often the referenced works can be improved, and this way students learn from the mistakes others have made. They also understand that uncritical copying of someone's work might have negative implications, and we are all aware that it is a very thin borderline between the tolerable and the intolerable use of other parties' work. But we believe that openness is the best approach to this issue. Findings do not lose momentum is maybe the most important thing that we've learned. One must avoid really everything that is hindering the students to progress with their works. This can be simple things such as the availability of material resources, for example. It could also be plagiarized work that the students then turn into their own with the aid of faculty. So carving out the aspects to be improved, aiming at the student, understanding the principles, and then use these to develop original work that is truly the student's own work. Let failure happen. We do not have to solve every single problem before students actually encounter it. And again, not to lose momentum here is really the key. Use what is available. Restrict the usage of materials and tools to what is at your disposal. Selecting from a variety of opportunities often demands far too much from the students, and that could result in stagnation. And foster state-drive designs. So let students work on a restricted period on a design problem. Don't give them access to anything else but pen and paper. And that indeed sounds a bit traditional, but it avoids plagiarism and it helps the students to focus on what we think really matters, and that is the development of their own skills.